All right, y'all, this is free response problem number 3. If you have not already worked this, remember I'm strongly recommending that you time yourself for 10 minutes before watching this video, just like if we were doing it 2 a day in class. So let's get started. So they give us this graph right here. It's the graph of g of a continuous function, the derivative of, so this is the derivative of f of x. So that's going to be important later. The function g is a piecewise linear function, and it gives us a function from -5. It's piecewise linear from -5 to 3, and then from 3 to 6, it's a parabola, and you can pretty much see that. So part A asks, if f of 1 is 3, what is f of -5? So that means that we are going to need to integrate this. So for A, we are going to do f of -5 is equal to f of 1 plus the integral from 1 to -5. Now of g of x dx. Now the first thing that I notice is that the limits are backwards. So I'm going to flip them and make it negative. So I'm actually going to have f of -5 is equal to f of 1 minus the integral from -5 to 1 of g of x dx. Okay. Now, if we are finding that integral, let's go back up and look at our graph. All of those pieces are piecewise. So if you'll notice, we have this portion here, and then we have this triangle here. And then from -1 to 0, the area is 0. So you have a couple of different ways you could break this area up. I'm going to show you the one. And then we can talk about it a little bit more. So here, my f of 1 was 3. And then I'm going to subtract from that. Now, if we look at this trapezoid, we can actually break it up, and I would encourage you to do this, into, let's see, you can break it up into a square and then a triangle, right? So that's actually what I'm going to do. I'm going to do -9 because that square is negative, and then -3/2 because that's the area of that triangle. And then if I look at this triangle right here, the area of that triangle is 1. Okay, and then that's all you have to do to get full credit. If you want to see a simplified answer, it was 25/2, but remember, you don't have to simplify. So how do the points break down on this? You got a point for the integral, and I think the top one also would have counted, and then you got a point for the answer. Okay, so that's 2 out of our 4 to 5 points that we typically hope are easy. And then for B, let's look at B. So B wants us to evaluate the integral of g from 1 to 6. So let's look. Again, I'm going to erase these marks because I can. So if we want to go from 1 to 6, I'm actually going to need to break this up, right? So the integral g of x, the integral from 1 to 6 of g of x dx, I'm going to need to break up into more than one piece. So if you go back up to I am going to break it into a square and then this parabola right here. So my first part, I can just calculate the area of the square, which we can see is 4. So my first area, I do want to go ahead and show that I split it into 2 pieces. So I'm going to integrate from 1 to 3 g of x dx. And then I'm going to integrate from 3 to 6 g of x dx. So my first area is going to be 4, and then I'm going to want to integrate from 3 to 6 2 times x minus 4 squared dx. Okay, so then remember this is a calculator inactive question, so I'm going to have to integrate it by hand. What's nice is the u that they gave me, the derivative is 1. So I'm going to bring down the 4. The 2 comes along for the ride. I get x minus 4 cubed divided by 3. And I'm going to evaluate that from 3 to 6. So I'm going to end up with 4 plus 2/3 times 6 minus 4 cubed divided by 3 minus 3 minus 4 cubed divided by 3. And then again, you do not have to simplify this. The simplified answer, just in case you were wondering, 10. Okay. So let's see how the points break down. You got a point for splitting the derivative into 2 pieces. You got a point for taking this antiderivative, and you got a point for the answer. So if we're trying to get those easy 4 to 5 points, those are the easy 4 to 5 points. Okay. So for C, what is C asking us? For C, for -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Now remember, G is the same thing as f prime. So if we want it to be increasing, remember I taught you to write the reason first. So if we would want it increasing, that would mean that G of x is positive. And then the other thing was it needed to be concave up. And the derivative would be increasing if the original function was concave up. Okay, so we're going to go back to the graph of G and see where that's true. So we want increasing and concave up. I mean increasing and above 0. So I'm increasing here, I'm increasing here, right? And so I see 2 places where I met that criteria. So I was increasing and positive from 0 to 1 and from 4 to 6, okay? And then put a because in between these 2. All right, and then you got a point for the interval and a point for the answer, just like normal. And then for D, D asks us, find the x coordinates for each point of answer. All right, so here we would want to change from increasing to decreasing or from decreasing to increasing. So I do want to acknowledge real quickly that most of this graph is increasing. It's increasing from 5 to 1. It's not doing any type of that behavior from 1 to 3. And then again from then it doesn't really change direction, but it starts decreasing here, and then it actually changes direction at 4. So the only point of inflection is going to be at x equals 4, because that's the only place that the derivative graph, which in this case is g of x, changes direction. So let's go ahead and say x equals 4 because g of x changes from decreasing to increasing. All right, and that is it.